Hi, welcome to this video. My name is Phil and I'm a senior lecturer in astrophysics at the University of Lincoln, and I want to go back to galaxies yet again, but this time round I want to have a look at galaxy merger trees and why they're important for things like galaxy formation and evolution. They help us understand kind of the history of a galaxy. Now, if you're not familiar with galaxies, I mean, if you've seen some of my other videos, hopefully you'll understand kind of now what a galaxy is, but just a very quick brief overview. These are enormous systems that are comprised of stars, gas, dust, also dark matter, and they're gravitationally bound. So some of these are kind of like disc-like, some of them are more spherical, so they have basically a whole range of different shapes, sizes, and even compositions. So whilst they do contain stars, gas, dust, and all that, different ones contain different amounts of some of those elements. So elliptical galaxies have very little gas content, for example, whereas spirals have a lot. Anyway, so these are massive systems basically. And this is the Hubble classification system for galaxies, and it looks a bit like a tuning fork. And on the right hand side you have your spiral galaxies. Along the top branch you've got your normal spirals with like a spherical bulge in the centre. Along the bottom you've got your barred spiral galaxies, which is like the Milky Way essentially. Sometimes in the middle you have an intermediate one where it's not quite a barred galaxy, not quite a normal spiral galaxy. It's like a weak barred spiral galaxy essentially. So those spirals sit on the right hand side there. You then have your elliptical galaxies, which sit on the left hand side. Now there are other sorts of galaxies as well, but these are like the two main types essentially. Now elliptical galaxies are mostly defined by their shape. So E0 elliptical galaxy is mostly spherical, E7 becomes more cigar shaped. That's pretty much it. But generally elliptical galaxies don't have spiral arms, they have little gas content in them, they have little star formation. So they're basically almost the opposite of a spiral galaxy. Now generally the formation, also the evolution process for a galaxy is going to be from right to left. So they go from spiral to ellipticals. And on the branch of the spirals, then their movement across to the left hand side is how they evolve. So their spiral arms get more tightly wound, they lose less gas, they actually get redder as they go towards the elliptical galaxy. Now it can happen in a few different ways. If you have an isolated spiral galaxy, they can over time essentially evolve into an elliptical galaxy, more spherical. They lose that disc-like structure, and it's because there's a redistribution of angular momentum, and those spiral arms essentially dissipate. All of the gas gets turned into stars, so there's no gas left, and then the stars themselves actually age, so they become redder. So an isolated spiral galaxy can form into an elliptical galaxy. However, if galaxies are not isolated, and actually the vast majority of galaxies tend to cluster in like gravitationally bound groups or clusters essentially, so they're not on their own, they are kind of in these large groups that are interacting as well. And here's an example basically. So you've got a nice galaxy cluster here that's got lots and lots of members, so you can have up to over 1,000 individual galaxies in a cluster. Groups would have a lot less, so like less than 50, but in these particular clusters they're quite densely packed, so the density of galaxies can be quite high, specifically in the center of them actually as well. And because of that, the galaxies get close to one another, they can interact, they can collide, they can tidally distort each other. That all impacts their evolution, how they form, things like that. So over time, what we'd expect to see in these clusters is that the spiral galaxies collide with one another, they merge, they grow bigger, and over time what will happen is the spiral galaxies will then evolve into elliptical galaxies through mergers essentially. So this then brings us to a galaxy merger tree. So a galaxy merger tree essentially represents the history of these galactic mergers as they're colliding and growing. So if we actually look at the top there, at the top we've got kind of the early formation ones, so these are the younger galaxies, and over time those smaller ones will kind of group together, they'll collide and merge, you get bigger ones, and then that brings us to like the present day galaxies. So here we've got quite small spiral galaxies slowly evolving into a large elliptical galaxy. So it's basically the history of all of these merger events for a galaxy. And it also kind of relates to redshift as well. So redshift also relates to distance, time, because the further back you look in the universe, the further away that it is. So actually, if we were to look back through a merger history tree, or a merger tree for the galaxy, you're essentially looking back in time, further away in the galaxy, so you can look at the early formation process as well, which relates to the redshift. Now, it's like a family tree, but for a galaxy. Now, because I'm British, obviously I've put kind of the family tree for the royal family here, and it's basically the same sort of thing really. You have your parents, so you have two galaxies, they will then kind of merge to then create a child, essentially, a child galaxy. So it's the same sort of idea really, although it doesn't look the same here. It's the same sort of idea. You've got the branches and then the individual galaxies. So an individual node on this galaxy merger tree represents a galaxy at a specific point in time, and then the branches represent the merger events. So the branches are where the galaxies are actually kind of merging together, and then the next one would be the new galaxy at a specific point in time. Now, this is an example from the Millennium simulation. Now, what they've done here is they pretty much tried to model the entire universe, large scale structure where you have these clusters, filaments from dark matter and stuff like that. And they've essentially followed the brightest cluster galaxy, and they've got its merger history there. And this is actually in look back time. So actually at the top, you've got kind of the present day, and then you're looking back at all of those galaxies that have kind of merged with it to create this large, bright cluster galaxy. Now, I've done a separate video on that, but these are the brightest, largest galaxies in a cluster. So it makes sense to kind of follow one of those. They're going to have a significant amount of mergers going off. So this is, you can get it from a simulation. You can also basically, it just tells us the history of a galaxy and how it came to be from mergers essentially. So thank you for watching, and if you enjoy or find it helpful, then do consider becoming a member of the channel. There's extra videos in the members section, but it also helps support the channel. So thank you for watching.